My name is Amir, and I'm pleased to introduce our panel on driving forces, automotive and defense industry approaches to software-defined vehicles. I'm going to intro our panel here quickly, and then we'll go ahead and get started. So sitting to my left is Tim Booher, Vice President of Autonomy at Boeing. Prior to Boeing, Tim served as the Vice President of Combat Systems at Lockheed Martin Corporation. He was the Chief Technical Officer of Cyber at HSBC. He served as a senior IT and cybersecurity leadership role at Colgate-Palmolive Company and the U.S. Department of Defense. Earlier, Tim held various roles at Polco, the U.S. Air Force, MIT Active Materials and Structures Lab, and Maatta Engineering and Education. Tim began his career in 1997 as a software developer at Star Legal and earned a BS in Aeronautical and Astronautical Engineering from MIT. Next to Tim, we've got Paige Kassalen, Chief of Staff at Saab for Strategy. Paige has an electrical engineering degree from Virginia Tech and a Master's of Information Systems Management from Carnegie Mellon with a focus on artificial intelligence. Paige began her career as the only American engineer working with Solar Impulse 2, the first solar-powered airplane to circumnavigate the globe. This role landed Paige with a spot on the 2017 Forbes 30 Under 30 list, along with feature articles in Glamour, Vogue, and Fast Company. Since Solar Impulse, Paige has worked in manufacturing and finance industries to implement a range of emerging technology trends from autonomous vehicles to machine learning. And she was the Chief Operating Officer at Crowd AI, which was then acquired by Saab. And she now serves as the Chief of Staff for the Strategy Division. Peter Ludwig is next to Paige. He's the co-founder and CTO of Applied Intuition. Prior to Applied, Peter led software engineering for Android Automotive and was at Google for 5 years, both in product management and software engineering roles. Originally from Southeast Michigan, Peter has a bachelor's and master's in computer science from the University of Michigan. And last but certainly not least, Ryan Maatta is a marine engineering manager at Serco North America. Ryan runs the marine engineering department there, one of the oldest and most influential naval architecture and marine engineering firms in the United States, drawing from its heritage from JJMA, founded in 1958. Ryan is a King's Pointer licensed marine chief engineer and formal naval reserve officer. His design experience focuses on ship propulsion, reliability, and maintainability analysis. I'm going to move on to our session goals here. We really want to get this session started with a discussion around the concept of the software-defined vehicle. I'll start with Peter. Peter, you've worked closely with several automotive makers in the commercial industry as they transition to this concept of the software-defined vehicle. Can you describe what is the software-defined vehicle and what has this process looked like for SDVs? And why are they incentivized to do this?
Yeah, absolutely. So it's actually easiest to understand software-defined vehicles when you think about it in contrast to non-software-defined vehicles. And so in a legacy system, right, the software is built for the vehicle and it's shipped, and then generally it's never touched. And so you'll have software that is deployed and then lives on the vehicle for 15 years until effectively the mechanical components wear out and the next vehicle is built. The limitations of that approach, of course, is you can't add new software features and capabilities. One of the common automotive examples is self-driving technology to the vehicle over time. Whereas in a software-defined vehicle, you typically have high-power compute that's really core to the vehicle architecture, and you have the ability to update software in a very stable and reliable way and update that frequently over the lifetime of the vehicle. The fact of the matter is today there's roughly one American company that's, I would say, very advanced in software-defined vehicles. That's Tesla. And then there's a whole bunch of companies in China. I think we'll talk a bit more about that later. But that's the state of the landscape today.
Thanks, Peter. Tim, how do major defense manufacturers like Boeing see this shift to software-defined vehicles? And what unique challenges do you see as Boeing is making this transition specifically?
You know, one of the most important things when you look at something as complicated as an aircraft and a topic like software coming together is binning them into the right areas. In combat aircraft, there is strict separation between software that protects a pilot, software that runs a mission, software that flies the plane. Even those two, safety of the pilot and safety of flight, are going to be separated. the same is true in commercial aircraft, and you can do some innovative things to have a good separation kernel, so you can run on the same hardware with these things. But it's a very tightly coupled and highly constrained space to move through. What's really interesting is the ability for technology to make what is rigid pretty flexible. And we're doing a lot, and at Lockheed, we were doing a lot as well with things like the FMI interface to allow for reusability of components moving through simulation, having well-defined. The Air Force is really leading the way on this with OMS and AMS GRA, defined interfaces. Think about an API for embedded systems that allows for flexibility in mission systems. But the most important technology that allows for speed and quality in this area is verification and trust capabilities. DARPA is doing great work in this area. ARCOS, for example, is automatically certifying airworthiness artifacts. But if you think about a car moving fast, just to make an analogy for it, the speed of a car is enabled by the brakes as much as it is the engine and the airbags, and the ability for the operator to take risk is knowing the road and knowing that high speed can be managed with this set of risks. And the ability to let software define both agility and performance and throughput in whether mission and national security critical systems or safety critical systems like commercial airplanes is really gated by the ability to deeply understand what software does and to make sure that provenance and the assurance of that understanding hold throughout the supply chain and ecosystem that you're building. And it's kind of cool. A lot of tech is making that a lot better right now.
I want to pull on that thread a little bit. Paige and Ryan, curious how you guys are thinking about this as well in terms of this concept of human-machine interoperability and the ability for the operators to know exactly what to expect the machine to do is paramount as you deploy new capabilities. How do we keep operators up to date with the capabilities and the features that we're deploying when we want to accelerate that feature deployment, but still ensure that they are knowledgeable and understand the bounds of what they're accepting?
Yeah. So we talked about verification and validation. So trust is incredibly important. And I'm specifically working with the Navy, and my program, the DARPA NOMARS program, is a completely autonomous vessel, no provisions for manning on board. It's next generation in that we're not going to let people on the ship. So it's incredibly important to build the trust between the operators, whether it be the remote operator in theater on the vessel nearby, or the ships working with this vessel, knowing that the operators either aren't there, that it's fully autonomous mode, or that they're coming in proximity to a very large vessel that could collide with them that has a remote operator that skin isn't in the game. Our customer, DARPA, same as yours, we're self-certifying. So that's a process that we're coming through. We're using model-based system engineering to do that. But I do want to tie back to Peter's comments about software-defined vehicles, because I heard something different than what we were discussing, Tim, before we walked in, which is you're talking about block upgrade and pushing features, which has always been a problem for the Navy. We spent 6 months in retrofit, mostly to get those physical hardware systems removed from the platform and new ones plugged back in. But we were talking about, PMS 406, the unmanned office at the Navy, their open architecture is called UMAA. We're trying to figure out a way where individual companies can put the best piece into the platform so that we launch a platform with many vendors and you can plug and play a component. So you have a better computer vision system that works with your data fusion. You need a new sensor. We have an open architecture for that. But getting engineers to work together is what we were talking about, Tim, and that framework document has to be airtight, and you have to conceive of things that are inconceivable. So I don't know if we were at vertical integration is the best way to go about this, or we just haven't done it right in open architectures. I'm dealing with that today. I know you dealt with it on F-35.
Mm-hmm. That's a really good point. Sorry, Paige, go ahead.
Yeah, I was just going to add, Ryan, I love what you said about trust. And that's something that we're seeing a lot at Saab. So I'm part of a division called SCOPA by Saab, which is its accelerator for new emerging technologies like artificial intelligence and autonomy. And especially my background in the tech sector, I know that we have certain technological capabilities, but there is that trust component and socialization that needs to be done. So you can build it, but are people going to accept it? Are they going to want to use it? And even then take it that step further and build upon it and get to that next level of innovation. That's a lot of what we're trying to do with SCOPA, and we're just at the start.
And once you give it to a Marine, they're going to do things you never conceived of.
One more thing I wanted to add as well. So with software-defined vehicles, one of the interesting capabilities that's unlocked is actually every vehicle can also become a trainer. So when there's new capabilities that are being added to a vehicle, and the vehicle has screens and controls that are that are used by operators, I would vastly encourage everyone in the room that you should think of these also as capable of training soldiers. You should be able to enter into a mode where those controls are no longer mechanically linked to the vehicle, but you can actually have a simulated environment that provides training for new capabilities.
One thing to add is just that software is it's the most frustrating for those of you who've written a lot of software. You can end up lost in complexity really fast. And it's amazing to write software today where there's a library for everything you want to build, but you're picking up something that someone else wrote. And the beauty of software is that it's a human-developed domain that can bring you solutions to these problems over time. And I've seen in my career things go like the arrival of memory-safe languages and type safety, concurrency safety, locking down whole categories of things that used to eat up tons of cycle of test. And that visibility piece, particularly connected from model-based systems engineering, as you move from something like SysML to SysML2, where you've abandoned the classic UML construct and you have truly expressive components, you can take that, connecting a developer, they can move a wire in a plane, and they can understand what they did to the mission and what that does to our ability to win a war. They can go home at the end of the day knowing what the impact was, but most importantly, they can have confidence that moving that wire, it still met all the specs of a system. It's like developing with test-driven design. You can delete code and know immediately if you've had an impact on the rest of the system. And software can help you write software by surrounding a system and visibility and verification, which is why software-defined vehicles, I think, whether they're aircraft or submarines or robots or cars, are a pathway to a much faster innovation cycle because the scientific method gets embedded in software and we can keep improving it over time.
Yeah, so that brings me to another point of discussion. I think, Ryan, you and Tim both brought this concept up of being able to have developers that didn't necessarily build the system now participate in that system, right? So develop a new capability, develop a new module or something like that, and deploy it onto an existing current or legacy system to enhance the feature set of something that we already have. So when you think about this, we can take our iPhone, for example, as sort of the baseline example, and draw that out a little bit. You can go and download an app, and anytime you download an app, that developer doesn't have to go and work with Apple to integrate it with your iPhone. And so we've had some conversations over the last couple of years where that's sort of the idea that many programs in the DoD want to go as well. How do I take my platform that I'm developing today and make sure that tomorrow's technology can be deployed to that platform? How are you guys thinking about the ecosystem that sort of gets built up around this? How can you take a platform that you're building today and make it developer focused and developer oriented so you can bring on others outside of your organizations in the future to participate in that development cycle? Paige, do you want to start? I know you had some experience that may be relevant here.
Yeah, absolutely. And thinking about Saab's history, and one thing I should also call out is that Saab doesn't make cars anymore. So I know a lot of people have this very fond memory of Saab's automotive business, but really for 90 years we've been making fighter jets and submarines and other vessels. And we've been delivering, just like a lot of you probably in this room, delivering these robust solutions that have been meeting the needs of the customers for decades and decades. But these demands are changing. And that's what we're seeing at SCOPA. We're saying we can't do things the way we've been doing them before. We have to figure out how we can embrace the new technologies. And one piece of hardware we're starting with is our Enforcer 3 combat boat. So I was just out on the boat last week in San Diego, and it was completely built for plugging and playing with all these different sensors and figuring out how can we integrate third-party technologies. And so there were a couple ways we designed this. So number one, just knowing from the start we were going to need to integrate sensors and software from other companies, but then also with just the design specs, we know that there are some things that go around that. You need to have the weight, you need to have the space constraints, you need to have the power. So we ensured that was all going to be set up so we can easily bring in third parties. And then the final piece was just making sure, because we do have this 90 years of experience building robust systems, let's make sure everything we've been experts at are perfect. The electrical, the hull, the mechanical systems. We don't want to be testing the latest and greatest AI solution and then having a mechanical problem with the boat. So that's really what we're thinking about. The Enforcer is really our first step with that, but SCOPA is trying to figure out how can we do this with more and more projects and more of our solutions to, just make it easier for collaboration.
Do you guys see, so traditionally, the concept of sort of bringing other vendors on, bringing subs on, teaming, things like that, that's been around for some time. Do you see a world where we can take some of the systems that are being built now and sort of open them up such that this concept of like large integration efforts become reduced over time? So again, sort of taking that iPhone example, right? I download the SDK, I read the docs, and I can go and develop an app. It doesn't need me sort of on a subcontract with Apple to go and do that. How do you guys see that maturing over time? Is that something that, these are very, very complex systems, so the analogy isn't exactly applicable, but is that a world that you guys see as possible and desirable?
So not to make it too hard of a plug for our own products, but like as an organization, Applied Intuition, right, we provide our vehicle platform, a vehicle software platform, which is literally an IDE. It's an integrated development environment for building vehicle software, and then that can be provided to organizations, and it's thought of in the same way as like Xcode or Android Studio are thought of for iOS or Android development, but it is for vehicles. Of course, it's a competitive ecosystem. We're not the only ones with an offering like this. But I think when I think about interoperability and allowing multiple organizations to supply software for vehicles, it really comes down to show me the tooling. Like if you don't have the tooling, it's just not possible to make those things work together.
No, absolutely. And anytime you talk about open architectures and just for software development, you have to worry about security as well. So I think that's the elephant in the room. We're working in a CUI IL4 environment. Some products need to be much higher than that, so that's always a specific concern. But in my case, we're running a consortium. We're not traditionally a software development company. We have branches that do that, but I had to bring in that code, and we were fighting off the traditional performers in the space, L3 and Leidos. It was competitive in my program. We were able to come through that and get the program to build the ship, but I had to outsource a lot of that development. We do the engine room autonomy side. We have smaller businesses putting together the AI captain, the bridge autonomy. And without a system like this, without setting up a DARPA developer cloud, without having an open architecture, we wouldn't be able to compete with vertically integrated corporations that are typically in the defense market, because we sell engineering as a service. We're not an OEM traditionally. So we had to.
I'd just add the imperative is there. I know we've all got reasons. We do the work we do. In defense, you want to win wars, and you want to enable the nation you're serving to be successful, and for the people that put their life on the line to not get in a fair fight because you've given them a tech edge. And I think that the motivations that have to come together for that, companies want to do things when they're faster, cheaper, gain market share. Employees want to do things when there's joy, when there's meaning, when there's pride in what they do. And the Venn diagram between those things is meaningful, responsive work where people get to feel and understand the impact of what they're doing. The reason we have to get it right is we'll lose a generation of our smartest workers if we don't provide that experience to build our weapons systems. They'll build web apps that can do those things. They make profit. They have status in society. They feel what they do, and they see the impact of what they're doing. I think security and the tooling are critically enabling for that. Business models are also really important. And the good thing is the government is forcing those business models. That forces the primes to adapt to working that way as part of a consortium. It's an open question to figure out how will the accountability and integration actually work. When you look at something beautiful like an iPhone or a Ferrari, you are seeing incredible vertical control of excellence and accountability in that system. When you look at something like Linux, you're seeing something that has extreme control under the core group and acceptance criteria of getting into the kernel. For example, in no place do you have an open set of things that combine on their own. So there's a core need to figure out how to get this right, with the goal at the end of having awesome experiences for people that decide to move into this workforce, and having outcomes for the warfighter where they're using best-of-breed technology, and that's building real hardware faster. So we're not stuck in these long timelines. When we see self-driving cars in China, you know that that's a mirror of the next version of the J-20 or the PL-15. Their next missile, next fighter is going to be coming out with technology that bleeds over from the sectors that they have, and we can't have a gap between our most advanced technology and what actually gets to the warfighter, and we can't ignore it by building apps in a plane instead of by learning how to actually build the planes faster in a more modular, interoperable way.
Thanks, guys. I want to go down the road for this next one because I think everybody's going to have a little bit of a unique perspective on this. So Tim, we'll start with you. We see this desire to progress to systems that are more flexible, that we want to field capabilities faster than ever before. Curious from each of your perspectives, how do you feel that we need to make adjustments to the acquisition process itself to facilitate and ultimately incentivize vendors to actually do this, right? I think historically we've seen a desire to go build something once, capture that, and then go build a new thing after that. But how do we incentivize taking something and continuously iterating on it?
Keep momentum high, start small, and move to bigger systems so you can really understand throughput and adjust. If you look at something like autonomy, there would be three big pockets, like fast things you can change quickly. You look at Ukraine and what Ukraine is doing with weekly respins of the firmware and printing out drones in the backyard kind of stuff. Like the fact that Replicator is fueling that ecosystem is awesome because it gets a lot of garages moving and thinking and understanding. And big companies have to be doing that too. You move that into bigger but less flexible systems, and eventually you get reuse and interoperability down. You're testing software at that flexible area that works its way up the ecosystem into big systems. And that gets like a flywheel actually moving in this space, if you can do that.
Yeah, and from my side, it's really just a mindset change, and we have to be aware that the pace at which software can innovate is most times much, much quicker than the pace at which we see innovations in hardware. And so those two have to work together in order for us to be successful. So just having more people in the room that have those experiences on all sides of the fence and bring together the limitations. And I love what you were saying about the modularity component, right? Like we just have to get it out of our mindset that we're going to build something and manufacture it and then only replace it once the components break, right? You're going to need to keep iterating, keep replacing, and work at the pace that software can grow.
Yeah, my perspective on acquisitions, also now having experience in both the commercial and the government space, is I think the government should be a lot more open to purchasing commercial products, and that does not mean that the products are black box closed source, right? You can buy a commercial product that actually is open source or white box. I think there's today the government does buy a lot of software, but it's actually done in the form of services, and there's maybe a handful of companies that are capturing a large portion of those services. But the problem with buying software on an hourly rate is you're not actually encouraging the efficiency and the reuse that fundamentally is the advantage of software. In fact, you're encouraging the opposite, which is the organizations are incentivized to take as many hours as possible to capture all the dollars that are present in that services contract. Whereas I think actually a more productive model is more of a willingness to purchase products where a little more of the firm fixed price model, where there is more of a let's say a competitiveness, and then also a desire for reuse across systems, and then frankly I think also applying some pressure on companies to be more open with those commercial products. I think that right now there's too much of a coupling between let's say services and openness, like, oh, we're paying for the services, we make it open. If we don't pay for the services, it's not open. And it doesn't have to be that way. And that's the main thing I would want to see change in acquisition.
So, again, in the Navy, because that's what I can speak to, Amir, we're talking about a near-peer capability emerging in the Indo-Pacific right now. That capability is launching well over 170,000 tons of first-rate surface combatants. We need an asymmetric capability, and to be credible, we need it in the next 2 to 3 years. Traditional FAR-based 2-year-out POM capabilities are going to put us in a situation. Replicator Initiative is a fantastic one to acquire some of these asymmetric capabilities. The government also has created the OTA structure, so Other Transaction Authority, specifically for prototypes, because what we're talking about is taking COTS products and modifying them and putting them in conglomeration, the kind of stuff that Strategic Capabilities Office does, and deploying them quickly to the warfighter. On Global War on Terror, we did this with SOCOM. We basically gave them a piggy book and said, get the piggy bank, checkbook, and said, get the best equipment that you need now to deploy to the warfighter. There's ways to do this. The other things that are really interesting in the contracting world for me are SBIRs. So these small business set-asides, they have intellectual property rights attached to them. They're one of the best and fastest ways to get universities and small businesses and the literal geniuses in the field to create a portion of it, and then get a larger company to integrate that technology, that thought process into their products. So OTAs and SBIRs.
The concept of China has come up many times in the conversation today, so I want to shift for our last question specifically to that. Starting with Peter. So Peter, you recently visited the Chinese Auto Show and observed a growing tech divide between our capabilities and what we're seeing in China. How do you think this impacts the development of SDVs, both in automotive and defense? And then I want to turn it over to the rest of the panel to get your thoughts on how do we start to think about closing that gap? What are the major issues that we're seeing in terms of how it has come to be, and then how do we inwardly look to start closing that?
Yeah, so as a company, we don't do direct business in China, but there's just so much interesting activity happening there in the technical space that I spent a few weeks there about a month back, just doing competitive assessments, competitive benchmarking. So we went to the auto show, and then we did about a dozen different test drives in just commercially available vehicles. So we literally went to dealerships and just got test drives in all these vehicles. And we're extremely calibrated in commercial automotive in terms of, like, I've been in every vehicle from every global manufacturer and seen all the latest technology demonstrations. And what we saw in China was far beyond anything we were expecting. This delta roughly happened during COVID. So prior to COVID, the state of the Chinese auto sector was, I would say, like, the companies are interesting. These are upstart organizations. They're doing some innovative things, but nothing really surprising. But now post-COVID, I would say this past auto show was really like a coming out event, where again and again and again, I mean, the technology is incredibly impressive, far better than anything from global manufacturers, and it's simultaneously inspiring and scary, right? Obviously, there's a lot of ideas that these Chinese companies have taken from American companies and then really taken to the extreme. But also, I mean, there's such a close working relationship between all of these organizations and the Chinese government. We just have to be conscious of the fact that that technology will absolutely make it into their military vehicles, probably faster than we'd expect. There's one anecdote I want to share there as well, which was, I saw particularly impressive system. The engineering lead was actually demonstrating it. And I asked him, what did it take to build this system? He's being fairly open with me. He said, yeah, we put 1,000 of our best people on this project. They worked on it for the past 6 months, 7 days a week, 18-hour days. And then, of course, logical question is, well, how can you retain your employees if that's the case? And the answer is, well, there's an oversupply of engineers in China. So the job market is extremely favorable to the employers. And they can, for lack of a better word, they can somewhat abuse that employee relationship and really work people hard. And so it's the workforce is working extremely hard and building extremely impressive technology. And I do think American companies need to wake up a bit into the reality. Like we are now the laggards, and we need to catch up in a bunch of ways.
Tim?
I loved working. And when I was at Colgate, I worked a lot in China, set up data science teams in Beijing, Guangzhou. I could get so much done there because I had access to incredible amounts of data. I would prototype it there, start using it in the US, flush out all the e-commerce and consumer analytics, and then move to Basel, where our data science team in Europe was most constrained and limited. I think whoever gets the most cycles in will win. The best time to plant a tree was 20 years ago. If we don't, if we get 1 million hours in and they get 500 million because they've got more national will and more availability of data, that goes up against the world's most incredible innovation ecosystem that sees companies like the companies we're working with here rise up. To see something like an Anduril become a major player in defense is American dynamism at its best and is super exciting. Can we all go on that journey together, and can we have collective will and national will around what we want to do is the most important question. I think we need to learn a lot from what they're learning. It's great they publish a lot of their work. And when I was in OSD, we were writing software that helped understand where their research was at. And I think it's great that we're still a draw, but I think it's a motivator. It's an inspiring source of a lot of innovation, and there are wonderful people there doing really incredible work that we should be aware of what they're doing and clear-eyed to the threat that they would represent if that national will gets directed to reunifying Taiwan or other things that are not in our interest.
Paige?
Yeah, and at Saab, I mean, we know very clearly that we're in a technological race right now, and we're at risk of losing that race if we do not start innovating and we don't make the bets that we need to be making. And that's exactly one reason why we're investing in Scapa by Saab. And I know a lot of organizations have different innovation hubs, but we need more to come out, and we need people to not be passive and say, we'll see how this plays out for another organization, then jump in. Saab's the second manufacturing organization I've worked for, and I know that a lot of times these projects like artificial intelligence or autonomy, they can live in innovation shops and just get stuck in R&D. And we have to figure out how we can change that percentage of projects that get stuck in R&D and actually make it out onto the operating environment. And the thing here is that, of course, all organizations are worried about their bottom line and they're worried about hitting revenue targets. But especially in this race that we have, the US, all organizations need to be working together, and it's just much bigger than profits for us all.
I want to add, and Ryan, I want to get your perspective on this as well, but there's a really interesting, I think, relevant question from the audience here that ties in nicely with the concept of, hey, things get stuck in R&D frequently. We spoke a little bit previously about how there are many, many requirements for software being deployed, particularly in safety critical areas. And I suspect that that's why we see a lot of this sort of stuck into R&D mentality, is how do you the lift to mature something from, hey, this is cool, this works well in the lab, to, okay, now I can field this thing in production and it's verified to be safe is challenging. So how are you thinking about this friction between developing sort of the secure, the compliant, the safe solution versus one that is actively being developed, and sort of rather than predicting everything, you're able to identify them quickly and quickly resolve them? What's the risk trade-off there as we think about that technology gap. Maybe Ryan, I'll start with you since we didn't get to hear you on China.
So I asked Admiral Moten something similar. I said, are we willing to follow the SpaceX model, move fast, blow things up, iterate, and move forward? And there's no stomach for that in the defense space. You get one shot. You have to do it right the first time. If you don't, you're blacklisted, right? You don't get to do it again. So we're contending with that traditional attitude, and this ties back to the last question. So how do we overcome that? Well, we talked about it before. Traditionally, during the Cold War years, we were technology forward in the defense industry, and then it matriculated out into commercial industry. It's very evident now, especially with large language models and AI, that we're commercial forward, and we're looking to pull that into the defense industry. So I think those leaps have to be taken in the commercial side. The question is, how do you incentivize companies that are on funding rounds to bet on defense? And so we call this Death Valley in the business. I'm not in that side of the business, but it's very difficult when you're on an 18-month funding round to say, okay, well, the government's going to like this, and in 24 months or 36 months, it might become a program. They might release an RFI next month. So what the government needs to be is more open, more interested, issue those RFIs, give industry the kind of things that they're thinking about. I think the last speaker talked about the presidential priority list, maybe down to the technology level. That would be very helpful. And one of the things I mentioned in the last response was SBIR contracts. There's a problem with SBIRs that technology gets to like the 6162, 62, and it's called a SBIR farm. They never do a 6.3. We really need to work on transitioning both the startup technology and the 6.2 to 6.3 SBIR technology into platforms. And there's offices for things like that. DIU is one of them. We need to focus more on that, I believe.
Yeah, thanks, Ryan. We have one more question from the audience. Actually, a couple that are closely tied together. So, Peter, you mentioned firm fixed price model with regards to buying commercial software. Representative in the last panel, Representative Whitman mentioned that FFPs are the right way to contract for commercial software. That said, the recently published Army software directive stated a preference for cost type contracts. Maybe can you guys share your thoughts on what is the right approach here, and how do we level set some of these perspectives?
So I think it really comes down to the question of how custom is a system really to the end objective. And I think if you start with a mindset that a system is going to be extremely custom, you're going to get an extremely custom system that may be hard to maintain and hard to sustain over the long term. In commercial software development, though, we're actually forced to think from the other side, which is like we're never going to have a customer that's going to pay for the full development of our products. So like we need to have something that is going to have many common components, and then certainly we'll customize as we need for various customers. And so again, our perspective, working on both the commercial and the government side, is really to think from the mindset of a bit of it's healthy to force a system to have common components, and I think what firm fixed price does is it forces organizations to really think about efficiencies and how can we build something that's still going to be a great solution, but make it as efficiently as possible. And so I don't think there's ever going to be a situation where it's 100% firm fixed price, but I think that a healthy balance between the models is what's going to be necessary.
Specifically interested if anybody has a counterpoint to that in defense of the cost type contracts.
I mean, my core thought is that any contracting mechanism can work if a set of criteria are true. You have to have technical excellence on the government so they know what they're buying and they can effectively manage and specify the systems they need. You have to have a workforce that can get the job done, and you can't let the system ossify. It's got to feel urgent as you're leading that work, and so you can never get comfortable in that model. I do think that the firm fixed price has a great capability to force innovation. On the other hand, it's been a real challenge for traditional companies to figure out how to take the Army they have and move into a new model. and we've got to figure it out. You can't ignore the risks of building big and challenging things unless you have that pipeline to go from small to medium to large as you're managing risk, and you've got venture capital to kind of do that. So it's somewhere in the middle where I'd say any contracting model works, but you have to have the tooling that lets you get the job done and a customer that understands the technology, and then you'll figure out how to get the right contract for it.
All right, I think we got time for this one last one, and this is a fascinating question. So Peter, you mentioned the work expectations of engineers in China. How do we compete with that? Just from a talent pool perspective, we're a free market. Engineers will leave. You know, Peter, if you told me to come into work and stay here for 18 hours a day for 3 months, I would go somewhere else. How do we actually compete with that?
So there is no perfect answer to this. I do think this is fundamentally, it's a big challenge. And the reality is, right, Chinese universities have gotten good. I mean, a lot of the Chinese professors are trained at America's best universities. So they're learning the same things in those universities that American students are learning here. You have the population's enormous. The interest in STEM is enormous, far greater than it is in the US. You just have this enormous supply of talented engineers coming out of universities. So I think there is going to be a talent imbalance in STEM going forward. I think the greatest advantages that we have as the United States, I think our immigration policy supports brilliant people coming to this country. And then I think honestly, I mean, many of the smartest and best people that I've worked with in the tech industry have been immigrants. And so I think it's important that we continue policy that allow us to bring brilliant people from other countries to immigrate to the US to work on these things. And I think also AI technologies are going to change this field quite a bit. And I do think the greatest part about the American system, it is like the freedom aspect. There is like this craziness to the way that American corporations can operate, and that sort of craziness really encourages interesting innovation, like OpenAI and the things that Google Research are doing. Like these things are invented in America, and I think that those technologies are actually going to have an enormous impact on software development and engineering, even within the next 5 years. And so I think it's important that American corporations are deeply embracing these AI technologies to the maximum extent. And if we embrace them correctly, I think this can actually give us a competitive edge, even against an adversary which may have more people in the domain than we do.